For this presentation, our group selected a traveling salesman problem. Brianna, Faris, Michael, and Jenny will discuss the selected TSP and two different approaches that are possible to solve. For a TSP, N represents the number of stops that a salesman or truck must make in its traveling route. There are n factorial possible routes to stop at all of the spots. The problem is to determine the optimal route while minimizing distance. This would be inefficient to calculate by hand, especially for routes with hundreds of stops, so simulation is a much better alternative.
Approach greedy algorithm is a discrete event simulation due to the fact that after a stop has been chosen, the next stop is based off of the prior decision. Nearest neighbor aims to find local optimal by determining which of the not yet visited stops is closest to the current position of the salesman. Steps of a greedy algorithm to solve TSP. First, select a stop to begin at. Second, determine which of the steps is closest to the current position. Third, go to the next stop. Fourth, return to step 2 until all cities have been visited.
After 100 city locations were randomly generated using the greedy algorithm, the most optimal route found was about 93 length units. Though many sections of this route look optimal, there are a few very large jumps.
Our second approach is the genetic algorithm. This is Monte Carlo because it uses randomness to generate routes and city locations. Its purpose is to find the global optimal by minimizing the fitness function. It attempts to minimize route distances, meaning the fitness function is the sum of the distance between each stop. And the steps of a genetic algorithm are used to solve the TSP. And here they are.
After the same 100 cities were generated, the most optimal route was found on iteration 2543. The total distance for this route was about 55 length units. Being that this route is about 40 units less than the greedy algorithm, it is evident that this method is more optimal.